Okay, here we're going to do a problem with implicit differentiation. It's called implicit differentiation because y is not clearly defined. All right. So let's give you an example. Okay. So now we take the derivative of every term on both sides of the equation or the expression. All right, so we have 2 plus the derivative of 4y is 4, but every time we find the derivative of a y term, you write y prime equals 6x, and the derivative of 7 is 0. Okay, now we need to solve for y prime. So I'm going to subtract 2 from both sides. So now we have 4y prime is equal to 6x minus 2. Now I need to divide both sides by 4. That's 6x minus 2 over 4, which is the same thing as for 2 divided. So that's 3y minus 1 over 2. Okay, so here we have another problem. And remember, we find the derivative of each term on both sides of the equation. But every time we find the derivative of a y term, we have to write y prime. Sometimes you will write it as dy over dx, but that's still just to denote the derivative. All right, so the derivative of 5x is 5 plus 6y, it's y prime, is equal to 4x plus 7y prime. The derivative of 7y is just 7. Now we have something different here. Now we have y prime on both sides of the equation, which we needed on one side of the equation. So we have 6y y prime minus 7y prime, and I'm going to move this 5 to the other side of the equation, equals 4x minus 5. Remember, we still need to isolate y prime. So what will I do? I will factor it out here. I factor out a y prime. That leaves us 6y minus 7 is equal to 4x minus 5. In here, as you can see, like we said, our ultimate goal is still to isolate y prime, and that answer will represent the derivative. So I need to divide both sides by 6y minus 7, since it's being multiplied. So that will be y prime is equal to 4x minus 5 over 6y minus 7. And that's our final answer. Now on this problem, it's slightly different. We have to notice the product rule. So it's still implicit differentiation, but we have to use the product rule here. So now, my first term is 3x. The derivative of my second term, the derivative of y, is just 1, but that's 1 y prime, because it's a y term, plus my second term, which is y, and the derivative of the first term is 3. That's minus cosine x is equal to 0. All right, so I'm going to clean this problem up. 3xy prime plus 3y. I just want to put the coefficient in front of the variable. Minus cosine x is equal to 0. Now, I still need to isolate that y prime. So what am I going to do? I'm going to move, this is 3xy prime is equal to, first I'm going to move this cosine x over, is negative, on the other side is positive. This 3y becomes negative. And now, since we're multiplying by 3x, we need to divide both sides by 3x. So this is going to be y prime is equal to cosine x minus 3y over 3x. That's our answer.